This is the battery management system with its focus on controller wiring. I have several contactors, both running and charging. Each contactor is physically interlocked so that you can't have both energized at the same time, with its respective readback, normally open readback, going to a DC input into the controller. This part of the drawing focuses in on the DC wiring. Here you have your two power supplies that's coming from the AC source, and one is just your control power for your small units like your controller and things like power and things like that, and then your actual big power supply for charging your batteries. You have a COS, or current operated switch or transducer, that is utilized to tell the controller that each battery is being charged. You have your batteries, banks, or your batteries, and they're all combined through those contactors. So when you're in charge, you're not in run. And each run contactor gains or series the batteries together until you get your final pack voltage. Finally, I have a solar wiring drawing that takes the solar cells, each solar cell, and they run them back into the solar bank terminal box. That as long as you have your solar cells active, you'll have your solid state relay energized. And then each contact, negative to positive, is series through the relay until you have your final solar cells gain battery that runs into your inverter, which changes it to your three-phase AC and then out to the substation.